Hello everyone, my name is Dr.E.Purushotham, Associate Professor, Department of Physics, School of Sciences and Humanities. Today, I am going to discuss about the main concepts of special relativity or special relativity. So, special relativity yields several consequences from applying low range transformations at high velocities nearer to the speed of light among them. So, the main concepts of special theory of relativity are time dilation, number 2 length contraction, number 3 mass variance, and depending on this we can calculate the mass energy relation. The main effects of the special theory of relativity in this. Now I am going to discuss about first one, time dilation. So first of all I am asking what is time dilation? Can you imagine, is it time increasing or decreasing? What is the time dilation? What is the definition? Anyone please? So, the time dilation, when fast moving observer experience the time is passing more slowly than the stationary observer due to the relative motion is called time dilation. What I am saying, when fast moving observer, if you observe the fast moving observer and stationary observer, so when fast moving observer experience time passing more slowly than stationary observer due to their relative motion is called time dilation. Time dilation. So you can see here, according to the special theory of relativity, you can see here. So according to the special relativity, time is not absolute but relative to the observer's motion. When two observers are moving relative to each other at high speeds, they will measure different time intervals for the same event. An observer moving at a significant fraction of time speed of light will experience time passing more slowly compared to a stationary observer. This phenomena is called time dilation. What is time dilation? When fast moving observer experience time passing more slowly than the stationary observer due to their relative motion, that is called time dilation. So according to special relativity, time is not absolute but relative to the observer's motion. When two observers are moving relative to each other at high speeds, they will measure different time intervals for the same events. An observer moving with a significant fraction of the speed of light will experience time passing more slowly compared to a stationary observer. Effect is called time dilation. So derivation of equation for time dilation in terms of velocity. Just assume here, so I am taking here two systems. So this is the origin, this is the S system. So I am taking, this is O dash origin, this is S dash system. The S dash system is moving with a constant velocity v. So you can see here, consider two systems S and S dash. Let S dash be moving with a velocity v. S dash be the moving with the constant velocity v along the positive x direction. Suppose a clock is situated in the system S at a position x, at any position of x, and gives signals at interval, time interval dt. For example, just imagine here this is the P, from O to P, this is x, this is x. So, that particular time interval, if we observe, let that is delta t in system S. So, delta t is given by, the time interval is given by, this is delta t is equal to T2 minus T1, let this is equation number 1. If this interval is observed by an observer in system S dash, then the time interval delta t dash recorded by him given by delta t dash is equal to, you see here delta t dash is equal to T2 dash minus T1 dash. What we are observing here, consider two systems S and S dash. Let S dash be the moving with a velocity v with respect to S in the positive x direction. Suppose a clock is situated in the system S at a position of x and gives signals at delta t time intervals. Delta t is given by delta t is equal to T2 minus T1, that is equation number 1. Similarly, if this interval is observed in S dash system, then the time interval delta t dash recorded by the observer. From low range transformation equations, we can write, so delta t dash is equal to T2 dash minus T1 dash. From the low range transformation equations, you know this is the delta t dash T1 minus Vx by c square by root of 1 minus V square by c square, this is T2 dash. In general, T dash is equal to T minus Vx by c square all divided by root of 1 minus V square by c square. This is the low range transformation equation, we know very well. So, for in system S, I am taking this is 1, this is 1. So, we get equation 3, T1 dash is equal to T1 minus V of x by c square by root of 1 minus V square by c square. In S dash system, just to take this is 2, this is 2, we get equation 4, T2 is equal to T2 minus Vx by c square by root of 1 minus V square by c square. So, again once again you try to understand here, this is the low range transformation equation, T dash is equal to T minus V of x by c square all divided by root of 1 minus V square by c square. Just to substitute here 1 1, we get equation 3. Just to substitute here 2, this is 2, we get equation 4. Now, substituting this equation 3 and 4 in equation 2, what is equation 2? You can see what is equation 2, delta t dash is equal to T2 dash minus T1 dash. You can see here, just to substitute delta t dash is equal to T2 dash minus T1 dash. So, this is delta t dash is equal to T2 dash, just to substitute this equation 4, here substitute equation 4, here substitute equation 3, we get this is delta t dash is equal to, we can see T2 minus V of x c square by 1 minus root of 1 minus V square by c square. So, minus delta t dash is equal to delta t dash is equal to T2 dash minus T1 dash. So, this is T2, I substituted here as it is equation 4 T2. So, T2 minus T1, this is the minus, this is equation number 3, I am substituting here. So, this is T2, next step, this is T2 minus T1 or simply T2 minus T1. So, I am taking total, this is root of 1 minus V square by C square. So, remaining this is T2 minus Vx by C square minus of T1, this is minus T1, this is minus into minus, this is plus Vx by C square whole divided by root of 1 minus V square by C square. So, here this is minus value, this is plus value gets cancelled. Minus Vx by C square plus Vx by C square gets cancelled. Remaining delta T dash is equal to, this is T2 minus T1 by root of 1 minus V square by C square. So, what about this T2 dash minus T1 dash, that is the delta T. Just substitute here delta T, we get delta T dash is equal to delta T by root of 1 minus V square by C square. So, we can see here delta T dash is equal to delta T by root of 1 minus V square by C square. This is equation number 1, equation number 5. Okay, the equation 5, this equation shows that delta T dash is greater than delta T. It means that the time interval in S dash system is greater than the time interval in S system. So, observations, we can clearly observe here, number 1, V less than or equal to less than C. So, second one, V is approximately is equal to C. Number 3, V is equal to C. So, observations we can observe, clearly take, this is 1, this is 2, this is 3. Okay, number 1, we take V less than C. Number 2, V is approximately is equal to C. Approximately is equal to C. Number 3, V is greater than or equal to C. You remember, in this observations, first observation I am taking here number 1. So, this is number 1. V is less than C, then V square by C square will be equal or greater than unity. Then what happened? You can see here. So, we are observing here V is less than C, then the factor V square by C square is negligible. Negligible means V square by C square approximately is equal to 0. Just to substitute delta T dash is equal to delta T by root of 1 minus V square by C square. At this place, just to substitute delta T by root of 1 minus 0. So, we get delta T dash is equal to delta T. The time interval recorded by a moving clock is the same as that when it is at rest. In S system and S dash system, we can be observed the same time interval. What we are observing here? For example, in first case, V is less than C. So, V square by C square. So, V is very small, that small is equal to 0. So, V square by C square is negligible, it approaches 0. Substitute delta T dash is equal to delta T by root of 1 minus V square by C square. At the place of V square by C square, I am taking 0. So, delta T dash is equal to delta T. There is no change in S system time interval and S dash system time interval. So, we can say that V is less than C, then the factor V square by C square will be negligible, small compared to the unity, hence delta t dash is equal to delta t. The time interval recorded by a moving clock is the same as that when it is at rest. Okay, second observation. This is the second observation. If V is approximately is equal to C, V approximately is equal to C, then you see here, for example, this is the second one. So, V is approximately is equal to C, then root of 1 minus V square by 1 minus V square. For example, this is root of 1 minus 0, 1 minus 0. Okay, second one, this is second one. If V is approximately is equal to C, the root of 1 minus V square by C square is less than unity. Less than unity means less than 1. Therefore, we get delta t dash is greater than delta t. That is, the time interval recorded by a moving clock is appears to be greater than the time interval between the same events recorded by the clock when it is at rest. So, if V is approximately is equal to C, then the root of 1 minus V square by C square will be less than 1, less than unity. Therefore, delta t dash is greater than delta t. Then the time interval recorded by a moving clock is appears to be greater than the time interval between the same events recorded by the clock when it is at rest. So, the third one, this is number 3. When V is equal or greater than, or V is greater than or equal to C, then V square by C square will be equal or greater than unity, equal or greater than unity. Then delta t dash is approximately is equal to, so we can clearly observe here, this is second one. So, last one we are discussing third one. So, V is approximately is equal to or greater than C, V is greater than or equal to C. So, the value V square by C square is equal or greater than. For example, delta t dash is equal to delta t by root of 1 minus V square by C square, this is the formula, V square by C square. V square by C square is equal to 1 or greater than 1. For example, equal 1, delta t dash is equal to delta t by root of 1 minus 1. So, this is delta t by 0, that is infinity value. So, we will get this is infinity value. So, delta t dash is equal to infinity or imaginary. It implies that no material body can move with light velocity, or no physical object can travel at speed of light. You can clearly see this implies that delta t dash is equal to imaginary. It implies that no material's body can have the velocity equal to or greater than the velocity. It means that, or it implies that no material body can move with light velocity. There is no physical object can travel at the speed of light. Depending on this topic. So, we are going to discuss twin paradox. Depending on the time dilation, we can explain the twin paradox. The time dilation effect leads to the famous twin paradox of special relativity. To understand the concept of a twin paradox, let us consider a hypothetical experiment involving twins. One twin stays on the earth. Let us take two twins. Let us take two twins, A and B. One twin A stay at earth, and the other twin called B travel into the space. He is moving into the space with speed comparable to the speed of light and then returns to the earth. What I am telling, the twins A and B, the A is at rest on the earth, the B is moving or B is traveling to the travel. After few years, the twin B returns to the earth. During this journey, as B travels at speed of light, which leads to time dilation according to the principle of special relativity. Hence, B age at the slower rate and at the end of the trip. When she or he joins her twin on earth, she will be younger than Sita or younger than A. So, what I am saying, another, consider twins with one of them going for a long journey to space at a high speed in a rocket, and the other remaining twin on the earth. The clock in the moving rocket appears to go slow for the observer, that is twin on the earth, in according to the principle of delta t dash is equal to delta t by root of 1 minus v square by c square. Therefore, when the twin returns back to the earth, he or she will find himself younger than the twin who stayed back on the. Again, I am discussing here, due to that the time dilation effect leads to the famous twin paradox of special theory of relativity. To understand the concept of twin paradox, let us consider a hypothetical experiment involved in the twins. Let us take two twins, A and B, she or he, as you are like. So, one twin stays on the earth, let that is A, and the other twin, let's call her or him as B, travel into space with speed comparable to the speed of light and then returns to the earth after few years. So, during this journey, as B travels at a speed of light, which leads to time dilation according to the special principle of the special theory of relativity, and the time dilation principle delta t dash is equal to delta t by root of 1 minus v square by c square. You can consider here the time dilation delta t dash is equal to delta t by root of 1 minus v square by c square. Due to this principle also, the B age at a slower rate and the end of trip when joins on the earth, the B will be younger than A. This is the time dilation with the twin paradox. So, consider two twins, simple, with one of them going for a long journey with a high speed of light in a moving space or rocket or any other, and the other remaining twin on the earth. Due to the clock in the moving rocket appears to go very slow depending on time dilation due to the principle delta t dash is equal to delta t by root of 1 minus v square by c square. Therefore, when the twin returns back to the earth after a few years, he or she will find himself or herself younger than the twin who stayed back on the earth. So, today I am going to discuss about length contraction. In our previous class, we discussed about time dilation. So, the main concepts of special relativity. Special relativity yields several consequences from applying Lorentz transformations at high velocities, that is nearer to the speed of light among them. The main concepts of special relativity are time dilation, length contraction, mass variance. So, first one completed in our last class. Today, I am going to discuss about length contraction. First of all, I am asking what is length contraction. Contraction means decreasing. The length is decreasing. For example, an object is moving with high speed. The stationary observer on the earth can be observed. The length is decreasing. Effect is known as length contraction. Length contraction. So, what is the definition of length contraction? According to the special relativity, or the special relativity also showed that the length of an object moving at a high speed will appear shorter in the direction of its motion when observed by a stationary observer. This effect is known as length contraction. But what is the definition of length contraction? When an object is moving at a high speed relative to an observer, it appears that object length shorter in the direction of its motion as observed by that stationary observer is called length contraction. Derivation of length contraction in terms of velocity. Let us consider the system. This is the, you can see this is S system, this is S dash system. Let S and S dash be two interval frames of references. Let S be at rest and S dash be moving with a uniform velocity v with respect to S along the positive x direction. So, as it is about the S system and S dash system, we discussed in Lorentz transformation equations and also time dilation also. So, the figure and same explanation is same. Consider two coordinate systems S and S dash. The S is at rest, S dash is moving with a uniform velocity v, uniform velocity v. Let a rod be placed in S dash along x axis as shown in figure. So, let this end is rod, left side end is B, A, right side end is B. So, AB is equal to L dash. This is the actual length, L dash. So, if x1 dash and x2 dash be the coordinates of the rod, then its length L in the system S is given by L dash is equal to x2 dash minus x1 dash. You see here clearly, consider a rod AB, that length is L dash. Let x1 dash, clearly you see here, this is x1 dash, the distance between S dash to rod first left A, that is S dash to A, that is x1 dash. So, from S dash system to point B, let that is x2 dash, x2 dash. So, let x1 dash is the coordinate from O dash to, this is O dash or S dash, this is O. S dash to or O dash to A is the x1 dash. Similarly, the x2 dash coordinate is the coordinate from O dash to B, then its length L dash is given by L dash is equal to x2 dash minus x1 dash. You see clearly equation number 1. If x1 dash and x2 dash be the coordinates of the rod, then its length L dash is given by, in S dash system, L dash is equal to x2 dash minus x1 dash. Now, let an observer in S frame measure the length of the same rod. Let x1 is the coordinate from O to A. You see. So, from for example, from S to this point A, this is x1. x1. What is, let an observer in the same frame, S frame, measure the length of the same rod. Let x1 is the coordinate from O to A or S to A. This is O to A or this is S to A. This point to this point, that is x1. You see here x1. So, x2 is the, similarly x2 is the coordinate from O to B. This is B, O to, you see up to this point B. This is the point B, O to B or S to B. Then the length L of the rod is given by L is equal to x2 minus x1. According to Lorentz transformation, we have x1 dash is equal to x1 minus Vt by root of 1 minus V square by C square. Let this is equation number 3. x2 dash is equal to x2 minus V2 by root of 1 minus V square by C square. This is equation number 4. So, substituting equation 3 and 4, this equation 3 and 4 in equation 1, what is equation 1? L dash is equal to x2 dash minus x1 dash. So, this is the x2 dash value minus this is the x1 dash value. So, we get this is x2 minus V2 minus x1, this minus into minus, what is this? Plus. So, this is minus Vt, this is minus Vt, this is plus Vt, gets cancelled. Remaining L dash is equal to, we can write here L dash is equal to x2 minus x1 by root of 1 minus V square by C square. So, we get L dash is equal to x2 minus x1 by root of 1 minus V square by C square. So, x2 minus x1, what is x2 minus x1? You can see x2 minus x1 according to equation 2, that is L, x2 minus x1, L is equal to x2 minus x1. So, I am substituting here L dash is equal to x2 minus x1 L by root of 1 minus V square by C square. So, from this relation we can write here, from this equation we can write here L is equal to this L dash into this one. So, L is equal to L dash root of 1 minus V square by C square. The length of the rod moving with velocity V relative to the observer is contracted by a factor root of 1 minus V square by C square in the direction of motion. It is known as length contraction, or it is also known as Lorentz Fitzgerald contraction. Okay, observations. First observation, if V is less than C, this is the first point. If V is less than C, what happened? V square by C square is negligible or very small, very small. What is our equation? L dash, L is equal to L dash root of 1 minus V square by C square. In this equation, this V square by C square is negligible or very small. Negligible, we get L is equal to L dash. When V is very small compared to the light velocity, that is V is less than C, then the term V square by C square is negligible or small compared to unity. So, we can write L is equal to L dash root of 1 minus V square by C square. The term V square by C square is negligible. So, we get L is equal to L dash root 1. So, we get L is equal to L dash. The length of the moving rod or object is the same as that when it was at rest. At rest, the object is moving, length is, at rest object length is, both are same. The length of the moving object or rod is the same as that when it is at rest. So, second one, when V is comparable to C, that means V is approximately is equal to C. So, the root of 1 minus V square by C square will be less than 1, less than 1. So, will be less than 1 means L is less than L dash, L is less than L dash. So, the length of the moving rod or object is appears to be less than the length when it was at rest. What I am saying, the length of the moving object or rod is appear to be less than the length when it is at rest. So, next third one, V is greater than or equal to C. V is greater than or equal to C. When V is equal or greater than to C, so V is greater than or equal to C, V square by C square will be equal or greater than unity. So, we get L is equal to 0, L is equal to 0 or imaginary. A small correction here, L is equal to L dash root of 1 minus V square by C square. Just you observe here, equal or greater than, equal will be equal 1. So, L is equal to L dash root of 1 minus 1, that is equal to L is equal to 0 or imaginary. L is equal to 0 or imaginary. This impossible, hence no material body can attain the velocity of light, the velocity of light. So, it implies that no physical object can travel at rest. So, third point, when V is equal or greater than to C, V is greater than or equal to C, V square by C square will be equal or greater than unity. So, that L is equal to 0 or L dash is equal to imaginary, L dash is equal to imaginary. It implies that no physical object can travel at the speed of light, So, the contraction takes place. Next point you see here, the contraction takes place only along the direction of motion and remains unchanged in a perpendicular. For example, so about this point, this type of object is moving with a high speed. So, let this is length, this is breadth. So, the contraction takes place only along the direction. For example, it is moving along this direction. So, we can observe the contraction along L only, we cannot observe along the breadth. So, the contraction takes place only along the direction of motion and remains unchanged in a perpendicular direction. For example, the object is moving like this. This is L or this is B. If the object is moving along this direction, we can observe along this B change in that width. So, simply you remember, the contraction takes place only along the direction of motion and remains unchanged in a perpendicular direction. The contraction, next point, the contraction cannot be visualized though it really occurs. You can see here in this point. The contraction cannot be visualized though it really occurs. The contraction is reciprocal. The contraction is reciprocal. So, we can observe here, if two identical rods are at rest, one in frame S and other one is in frame S dash, each observer in its own frame observes that the other rod is shorter than the rod of this own frame. So, the contraction is reciprocal. Just observe the explanation. If two identical rods are at rest, one is in frame S and another one is in S dash frame, each observer in its own frame observed that the other rod is shorter than the rod of this own frame.